Hello, now we're going to look at angles and how they relate to something called parallel lines. So to begin with, we need to have a look at what it means for lines, or straight lines like we draw with our ruler, being parallel. So to think about parallel, we have to think about one of the properties of a line, which is to say its slope. So we can think about lengths of lines or points that lines go through. We can also think about the slope of a line. So if we think about what the word slope means in English, it means if we had a very steep slope, we'd be going up very quickly or down very quickly. If we were trying to run up a steep mountain, we'd have a steep slope to the mountain. It would be difficult to run up because we'd be rising so quickly as we run along. So the slope means how quickly we rise for how much we've run across. So if we look at this line L and this line K, every time we run across by 3, we rise up by 2. So its slope would be 2 over 3. Rise of 2 for every 3 you run across. And K has the same slope. If we run across by 3, we rise by 2. So our rise over our run is 2 over 3. So these two lines have the same slope. Effectively, when we draw them, they're going in the same direction. They're rising or falling in the same way. So they are what we call parallel to each other. So they have the same slope. They're going in the same direction. So this idea will become very important in the long run. The idea that parallel makes us think of the slopes of the line, that the rise over the run is the same for all of our parallel lines. How we write that mathematically, if we have a line L and a line K, we have L and then 2 vertical lines, 2 straight up and down lines, and then K. And this means L is parallel to K. The line L goes in the same direction or has the same slope as K. So that's one piece of writing, and you can see little arrows going on for our L and our K, and that tells us those arrows on the L and K tell us that those two lines are parallel. So visually, if we see those arrows in our diagrams, that means we can say those two lines are parallel to each other. And if we don't see those lines, then we can't assume that. Now, based on parallel lines and what we know about angles, there are a few things that come about, and they have different names. So the first one we're going to talk about is corresponding angles. And we say that corresponding angles are equal to each other. So if we have this green angle here with our dot as our label for it, so we can say this angle here corresponds to this angle here, because our two red lines or orange lines are parallel. How do I know they're parallel? Because I can see the arrows for them. So if I have my two parallel lines going here, my two orange lines parallel, and I have the blue line going straight through them, this is a straight line. So if these two lines are going in the same direction, then I must end up with the same angle on equivalent parts of my crossing. So my blue line crosses my two orange lines. These two angles here that correspond to each other, that are in kind of the equivalent place in each case, must be the same. And my yellow angle here that I've labeled with a little dash also must be the same. So this is in the same kind of position as this angle here. Are there any other ones that are corresponding that I would be able to label in? Well, what would be the corresponding point for that line there? Well, that would be this angle here. Is there any other ones that it would be corresponding that are in the same kind of position? Well, there's only one pair of angles that we can see left to us. So if we look at this angle here, I'll put 2 dots for here. The one that would be in the same kind of position down here would be this angle. So all of these angles correspond to each other. They're in the same position in each one of these crossings. So we say they correspond to each other, and we know that they are equal if we have these little arrows that say that these lines are parallel. If we don't have that, we cannot make that assumption. We can't assume it. Now, a closely connected idea is called alternate angles. So to alternate means to switch sides. So this is often called the Z rule, as a way of remembering the pattern that it has, because one of the ways that it works forms the letter Z. So if we look here at our green angles, we have our parallel lines and another crossing, very similar to the last time, but we can say that this angle here must be the same as this angle here. They are alternate angles. And this comes back, this actually builds from this idea and the idea that there are 180 degrees in a straight line. That's how we can get this rule. Now there's one that is slightly less obvious because it doesn't actually look exactly like a Z. But again, the simplest version of this is we have our Z going on here. But the same argument would hold if I had this angle here. So I'll put a dot there. If I imagine I stretched my Z out so it kind of went a little bit wonky, there's a Z kind of shape going on there. So these angles that alternate the side of the line must be equal to each other as well. So that's another tool we have available to us. And it comes directly from this observation and the fact that there are 180 degrees in our straight line. Another thing that's very closely connected to this is the idea that if we have our two angles on the inside of our crossing, so our blue line crosses here, and on the inside crossing, our x plus our y here are called interior angles. They're on the inside of my two parallel lines, and they must add up to 180 degrees. And this comes directly from these arguments here. Now let's put these rules into practice. Or actually, yeah, let's put these rules into practice and look at how to find some missing angles. So we'll start off with this case here. If I know that this angle up here is 130 degrees, how would I be able to find the angles A, B, and C? Well, there are several different ways that I can do this because I now know lots of different tools available to me. But the first one we're going to practice is our corresponding angles. So I can see I have 130 degrees here and I have my parallel lines. I know they're parallel because I can see my arrows. So that means that I could say that this angle would correspond to the angle A. So I can say that A must be equal to 130 degrees because of corresponding angles. And I know that I'm going to write down my rules as I'm using them so that I'm building that structure in my head for when these questions get more complicated. This storytelling matter of saying why things are true in geometry is extremely important, and we want to be doing it all the time. So we have A must be 130 because they're corresponding angles. They're in the corresponding or the equivalent position in our crossings. Now, is there any way that we would find the angle B? Well, there's a few different ways that we could find the angle B. We could notice that this is a straight line. So if we look at our blue line, and we have 130 plus B would have to add up to 180. So we could make that argument. 130 plus B would have to equal 180. And rearranging that rearranging that equation, I should say, would tell me that B must be equal to 50 degrees. There's another way to look at it, however. It's basically the same argument, but you come at it from a different angle. We now know that at A plus B, the angles interior, the interior angles, so for interior angles, I'll use the angle symbol, we'd know that at A plus B must be equal to 180. Again, this gives us the same formula, but it gives us to it from a different perspective. And in different questions, those perspectives will be useful. So we know that at 130 is my angle A, plus B is equal to 180. So I'd end up with B is equal to 50, just as before. So these are two different ways of approaching that question for finding the angle B. And then how would we find the angle C? Well, we have two options here as well. If we look at this orange line here, this red line here, A plus C would have to add up to 180, or more quickly, and as we've already used that argument, what do we notice our shape here? Well, we have our parallel lines and we have a Z. So if we have a Z, we know that we have alternate angles. So we could say that B and C must be equal to each other. So angle B equals angle C. Let me redraw that. equals C, angle B, must be equal to each other because of alternate angles. That means that C must be equal to 50 degrees. So again, we can tell our story, and there are multiple ways that we can tell our story. And it's important that we are practicing those multiple ways and explaining each step. Why is this true? Because B is equal to C because they're alternate angles, and we're laying down that foundation for harder questions. Now, in this question, we're asked to find X and Y, and I can see that I have parallel lines. So this line is parallel to this line. And then I'm able to say, well, if I get a question like this, I'm going to fill in all of the angles that I can. So what jumps out at me immediately is I have alternate angles going on. I have a Z going on here because I have parallel line, and I have a line going through. Even though this line doesn't continue on and this line doesn't continue on, I can see that Z shape between parallel lines. So that means that this angle here must be equal to 80. Well, how would I use that to find X? Well, I know in total this is a straight line, so I must add up to 180. So I know that 70 plus 80 plus X must add up to the 180 degrees that are in a straight line. So I add my like terms together, and I get 150 plus X is equal to 180. I rearrange my formula. I get X is equal to 30 degrees. Now, how am I going to find the angle Y? Well, in the long run, we will look at the fact that there are 180 degrees in a triangle. So we can spot we have a triangle shape here. But for right now, we're going to focus on the methods that we've got going on here. And what we can say here is that X and Y are corresponding angles. Sorry, I should have written in here that I was using the fact that that was an alternating. That they are alternate angles. That's why that's 80. Now, beyond that, how would we have that? We know that the angle X is equal to the angle Y because they are corresponding angles. So I tell myself that story, and therefore Y is equal to 30 degrees as well. Just to make sure that everyone's okay, if I put out a dashed line going that way and I put a dashed line going out that way, I can see that this angle here, so where would be the equivalent? That angle there would equal that angle there is kind of the equivalent that you can see. So these are corresponding. They're in the same relative position on my crossing. So this line is crossing my two parallel lines. So X must be equal to Y because they are corresponding. And again, we've told our story of how we know that as we are answering our question. And that's what we need for our angles and our parallel lines.